bila kawan you nak masuk, okay, stereo regularity of the structures. Okay, so nampak slide saya ke?
Nampak, madam.
Alright, so for the stereo regularity of the structure, we will look into the difference between the technicity and also the isomer. Okay, so before this, you learn about the conformation, polymer conformation. So for today, configuration. Okay, what is the difference between the conformation and configuration? First, conformation is about the bond rotation. Okay, apa benda ni? Kejap. The bond rotation is mean after you apply the energy, the bond will start to mobile. Okay, they have the ability to mobile, and also they will rotate at certain angles. That is a conformation. So conformation only occur in a single bond only. Where there is a presence of the double bond or triple bond on the backbone, the polymer is restricted to rotation. It means that when there is a presence of the unsaturated part, your polymer cannot rotate. They can move, they can vibrate, and then they can move, but then they cannot do a rotation. So conformation only occurs on the double bond. Meanwhile, in configuration is about the polymer arrangement. Okay, polymer arrangement when they are chemically bonded to one another. So for this configuration, okay, the order is determined by the chemical bonds, and these chemical bonds, they cannot be destroyed. Okay, they cannot be altered unless you break the bonding. You break the chemical bonding. Okay. So in the configuration, it can occur in both of the double bond or also the single bond. Okay, so let's imagine that this is the polymer atoms. Okay, polymer atom. So when these polymer atom are in one plane, it's mean in the arrangement. Okay, so this arrangement, okay, is called as a configuration. It means where they are placed. Let's say we have the circle and also we have a square. So the arrangement between the circle and also the square is considered as the configuration. So the bonding between the circle and also the square, they cannot be altered. It means they cannot be changed unless you break the bonding. Okay, so when there is a configuration in polymer, okay, you cannot alter the arrangement. But when you apply the extra high energy, such as you heat at the high temperature or pressure, and then this can cause the chemical the link to be broken. Okay, so at this time you can alter the polymer. Okay, so this bonding, they can be broken and they can be reformed back when you remove the energy, you remove the heating and so on, so they can be reformed. Okay, so in configuration, okay, in the molecular characteristic, you can do chemistry. It means how many repeating unit. Okay, you can classify your polymer. Okay, the polymer in terms of the size. Either they are high molecular weight or low molecular weight, and you can categorize your polymer molecule by shape. It means either there is a chain twisting or entanglement of the chain, and last one in terms of the structure. So under the structure, you can mention that this polymer either linear, branch, or cross-link, and also the network. So under the structure, under the element of linear and branch polymer, there is a terms of the isomeric state. So in isomeric state, there is two things, okay, two types of the isomers. The first one is the stereo isomer ataupun sometimes kita panggil sebagai stereo regularity. And also the second one is the geometrical isomer. So both of the stereoisomer and also the geometrical isomer is considered as the type of configuration for the polymer. Okay, so for the stereoisomers, it is about the arrangement of the functional group, the arrangement of the pendant group that attach to the polymer. So there is a tree which is the isotactic, symbiotic, and also the atactic. So these stereoisomers they occur in the single bonding. Okay, this in the single bonding. Let's say you have the PVC, you have the apa nama lagi? You have the polystyrene, polypropylene. Okay, but not all polymer can form the having the tacticity. Okay, having the isotactic, syntactic, or atactic. Okay, so these three elements of the stereoisomer can only be found in the certain polymer that having one functional group. Okay, so you can observe the arrangement of this functional group. But in certain polymer, let's say polyethylene and so on, you can mention their configuration and so on. But in terms of the repeating unit, because we know that in polyethylene, the repeating unit is same to each other. Okay, so you cannot find either they are isotactic, symbio ataupun atactic. So this only occur when there is a presence of different functional group. Second one, we have the geometrical isomer. So geometrical isomers is used to explain about configuration in a double bond or triple bond. Okay, so in the geometrical isomers, okay, the polymer is not rotated, but they can be formed when you apply when you during the polymerization methods. Okay, let's say you are using a different catalyst. Okay, so you will produce a different configuration. Okay, so certain configuration is known as a cis, and another one is known as a trans. Okay, okay. So in the ni macam dah repeat dah pula. Set, Okay, so for polymer configuration can be defined as a various polymer arrangement that are chemically bonded to one another, and they are determined by the chemical bond, and this chemical bond they cannot be altered unless they are broken and also reformed back. Okay, so under the configuration you can classify either they are tacticity, okay, yang stereoisomerism tadi, or they are isomerism. Okay, so in the tacticity it is a it is defined orientation of the monomer unit along the polymer chain, and they are especially related to polymer having a chiral center for their repeating units. Okay, so this is the requirement to for the tacticity. Meanwhile, the isomerism it describes the presence of several structure having a same molecular makeup. Okay, so in the isomerism, the molecular formula is same to for cis and also the trans. The only difference is the placement of the functional group, the placement of the molecule for that polymer. That's why we have a cis and also the trans. Okey, kita lihat kepada yang isomers dahulu. So, isomer describe the presence of several structure having the same molecular makeup. So, in certain atoms, they are in certain polymer, they having a same atoms. Okay, let's say we have the polymer A and polymer B. So, polymer A and polymer B, they having a same atoms. They having a carbon, okay, they having the double bond, and also they having, let's say this one is anything lah, okay, let's say hydrogen ke ataupun CH2 ataupun CH3. Okay, so they having a same atoms. Okay, the element is same for polymer A and polymer B, but then it is different in terms of the special configuration between the atoms. Okay, let's say in certain atoms they are placed in the same site. Okay, like this one. Kalau you lihat kat sini atom, let's say lah ini atom yang kita mention as a circle lah. Okay, this yellow circle, they are placed in the same direction, okay, in the same side. Meanwhile, in the polymer B, although they have a same atom as a polymer A, but the placement of atom yellow, this one, is different. They are opposite to each other. Same goes to the blue one. Okay, so they are different in term of the placement. Okay. Okay. So okay, ni yang contoh yang kita nampak di dalam atoms ataupun molekul untuk polymer. Okay, let's say in polymer, let's say if they are present of a single bond between the carbon just now, okay, you're having the carbon, okay, the red one is a carbon. So when this carbon, these two carbon are linked by the single bond, okay, this carbon, this polymer chain, they can rotate. Okay, when they are linked by the single bond, the rotation will be occur. Okay, so when this polymer can rotate, okay, they show no isomerism. It means they will continuously rotate. So you cannot find a definite isomers of this polymer, the definite configuration of the polymer, because it continuously rotate at certain angle. Okay, so every time they rotate, they will have a different terms such as trans, gauche, okay, or staggered. Okay, so they're having a different name. Okay, so this only occur when the carbon is linked by the single bonding. So when carbon linked by the single bonding, there is no isomerism happen. Okay, there is no configuration happen, only rotation. Okay, meanwhile, when these carbon are linked by the double bond, okay, they are unsaturated polymer, they are linked by the double bond. They, when there is a presence of double bond or unsaturated bond in the polymer that link between carbon, the rotation will not occur. Okay, so the rotation will be impossible lah. Okay, kalau kita lihat kat gambar rajah B ni, bila ada double bond macam ni, dia tak akan berlaku sebarang rotation lagi dah. Polymer awak tak akan rotate, dia akan vibrate but they will not rotate. So when they are having this double bond, okay, they will have a same more the same atoms. Let's say for the polymer B ni, you boleh nampak dia akan ada atom yang sama. Dia warna merah, dia ada warna putih dan juga dia ada warna hijau. So atom dia sama. Kalau let's say kita letak dia sebagai molecular formula, okay, the molecular formula will be C4H8 contohnya. So both will be C4H8. The only difference is where is the arrangement ataupun where is the configuration, okay, of the atoms. Okay, so when you have a same molecular formula but different arrangement, okay, you can term as a trans and also the cis. Okay, contohnya kalau kita lihat yang paling mudah lah, kita ada dalam rubber, natural rubber. So you can have either a trans 1,4 isoprene, okay, ataupun you can have the cis 1,4 isoprene. Okay, so the only difference is regarding the placement of the CH2. Let's say in rubber CH2, so the placement of this CH2. Okay, so if they are in the opposite side, okay, the CH2 in the opposite side, so they will consider as a trans polymer. Okay, but when they are in the same side like this one, okay, so they are considered as a cis, okay, cis polymer. Okay, so this one is not only occur in the natural rubber, in the polyisoprene, it can occur in various polymer. Okay, as long as they meet the requirement for the trans and also the cis. Okay, so we can have another element such as the we have the other arrangements such as the C4H8 like this one. Okay, you can see that we having the atoms, okay, such as the carbon that link by this double bond, and then you have the functional group of the hydrogen, dependent group of the hydrogen, And next you have the methyl group for each side. Okay. So when you have this kind of polymer, okay, the different arrangement of the CH3, okay, and also the H will determine either they are cis or trans. So as you can see here, okay, cis they are in the same side, and also trans they will be in the different side. Same goes to this one. Okay, contohnya macam ni kita ada dia punya functional group dia adalah Cl. Okay, so there we have a different side. Okay. So what is the effect of the cis and also the trans in polymer? As you can see from here, okay, when there is a different arrangement of the polymer, you can have a different the different properties. Okay, between the cis and also the trans, there we have a different properties. Okay, let's say for the cis, you can see that functional group, let's say this one, bulky functional group will be on the same side. Meanwhile, in the trans, the bulky side, the bulky pendant group will be on the different side, okay, in the alternate side like this one. Okay, same goes to this one. Okay, a very polar a very polar atoms will be on the same side, and another polar atom will be in the alternate side. So when polymer having high cis content, okay, it means the arrangement of the cis is more compared to the arrangement of the trans. The polymer will consider having a highly crystalline polymer because the atoms, the pendant group, arranged at the same side. So they are able to form the very regular pack arrangement. So polymer having the high cis content can be highly crystalline. So when you want to process the cis polymer, okay, the cis arrangement, you need to apply high energy so that because the melting point will be higher. Okay. Meanwhile, for the polymer that contains about 93% trans content, they are considered as the amorphous. So they will be more flexible, okay, because they having more trans content. Okay, what is the meaning of the cis content also the trans content? Okay, kita lihat balik contoh yang sebelumnya. So bila polimer awak terhasil, okay, they will have a either cis and also the trans. They can have both. It means in that one polymer chain, they will have a arrangement for the cis and they will have arrangement for the trans. So let's say if the trans element is more compared to the cis element ataupun amount of the trans is more than the cis, so the polymer will behave more towards the amorphous because when polymer is the highly in the trans structure, they will be amorphous. Meanwhile, if the polymer arrangement ataupun polymer configuration is more towards the cis arrangement, so they we consider as the crystalline polymer. Okay. So when they are trans and cis, the polymer will behave differently in terms of the crystallinity, amount of the crystallinity, ataupun they will behave in terms of a different thermal energy. Okay, melting temperature for the cis polymer will be higher compared to the trans polymer, even though they having the same formula. Okay, the same molecular formula. Kalau you lihat kat sini, contohnya C4H8. Walaupun dia punya atom sama, jumlah atom dia sama, katakan karbon dia ada 4, hidrogen dia ada 8. So it mean the the molecular formula dia adalah sama. Amount of carbon sama, amount of hydrogen pun sama. And both having a double bond. Okay, so everything is same. The only difference is the arrangement of this CH3. Okay, so when CH3 are at the same side, we know that when polymer at the same side macam isotactic, okay, so they can have a better ataupun a good arrangement. Okay, they can form a pack a pack arrangement. So polymer will be more crystalline. Meanwhile, for the trans, okay, even though they having a same atoms, same amount or composition of the atom as a cis, but the arrangement of the bulky group CH3 will be on the different side. So what happen is there will be less strength. There will be more towards the flexibility. They will be more flexible. Okay. So when they consider as a sekejap apa ni? Sekejap. Okay. Okay, sorry. Saya baru dapat berita pakcik saya meninggal. Sekejap sorry. Okay. So when apa benda saya cakap tadi lupa dah. So when cis will be on the same side, they will be more crystalline. So for the trans, they will be at the different side, so they are more amorphous. So we know that when they are crystalline, the melting point will be higher. But in this in this research, okay, in this one paper, they mentioned that for the cis and trans polymer, the melting temperature will be different, but they will have the glass transition temperature will not be affected. Maksudnya kat sini, you will need a high temperature to alter the polymer. You will need the high temperature to break the bonding between the cis and also the trans. But in term of the glass transition ni tak melibatkan sebarang bond broken ke, ataupun you tak perlu nak putuskan bond dia ke apa. Dalam glass transition, it only between the glassy and also the brittle. Okay, so it is only about the how flexible the polymer is, okay, in the glass transition state. Okay, so they found out between the cis and trans, the melting temperature will be higher, the Tm will be affected, but the Tg will less affected. Maksudnya in term of the flexibility, dia tak jauh berbeza antara cis dan juga trans. So they will not affect the Tg as much as they affect the melting temperature. Okay, so what else the others effect between the cis and trans polymer? In terms of the crystallinity, normally cis will form high crystallinity because they can be more regular and order arrangement. Trans will be less crystallinity compared to the cis. Meanwhile, tadi kita mention Tm will be high in the Tm for the cis polymer. Meanwhile, for the trans, there will be a lower Tm. Okay, there will less energy for the bond breakage. Okay. Meanwhile, for the flexibility, normally cis isomer, they introduce the flexibility in the polymer and they making the polymer less rigid compared to the trans. They are relatively straight and they having an extended structure of the trans isomers and they contribute to more rigid polymer chain. Okay. And for the Tg, for the trans and cis, they are not affected. They are slightly affected for the glass transition temperature for the cis and trans. Sebab itu, let's say dalam certain application, okay, contohnya you have the butadiene rubber. Okay, butadiene rubber is one example of the polymer ataupun polymer that will affected by the cis and trans content. Okay, contohnya butadiene rubber ni kita gunakan banyak di dalam let's say tire industry. You want to combine between the natural rubber and butadiene rubber. Okay, sebab apa? Butadiene rubber ni dia akan impart the wear resistance towards the rubber. So rubber will be more they have a better in term of the wear resistance when they have a high cis content. Okay, so when we include the butadiene rubber into the natural rubber, we combine. So what happen is you can induce a good characteristic ataupun a good properties in the wear resistant when you use the high cis content of butadiene rubber. So in butadiene rubber, you can have high cis content up to 97%. Or you can have a low cis content about slightly low lah. Maksudnya bukan terlampau rendah. Mungkin cis content dia antara lebih kurang dalam 90% sahaja. Okay. So when cis content between 90% and cis content at 97%, they will have a different properties in terms of the wear resistant. It means that when this butadiene rubber having a cis content about 97%, so they will offer more wear resistant to the rubber compound. Okay, compared to the 90% of the cis content. Okay, so that is how configuration between cis and trans will be affect the polymer properties. Same goes to the polyisoprene. Polyisoprene adalah natural rubber. Okay, so between the cis isoprene and trans isoprene, they will behave differently. And this one can be altered. The amount of the cis and trans will be altered by using the catalyst during the polymerization and so on. Okay, so for the cis and trans, okay, the amount of the cis and also the amount of the trans will will give a difference in the properties of the natural rubber. Let's say if your rubber having high cis content ataupun high cis polyisoprene, they will be highly in the elasticity and they having a low internal friction. So ini sambung dia, low internal friction. Meanwhile, for the trans polyisoprene, when the amount of trans polyisoprene is higher in the rubber, they will behave as a hard plastic. They will be more rigid, but they are more easily to crystallize. Okay, and this one can be altered. These properties can be altered by using the catalyst between the aluminium and titanium. Okay. So let's say if the catalyst is more than 95% of the cis polyisoprene is formed. Meanwhile, if the catalyst is less than 1, the 95% of trans polyisoprene can be formed. Okay, so this catalyst will affect the amount of the cis and also the trans in the polyisoprene. Okay, ini adalah butadiene rubber macam saya mention tadi. Okay, so the butadiene rubber can have a different cis and trans components, cis and trans amounts. For the high cis content butadiene rubber, they can achieve up to 95% of the cis content. Meanwhile, for the trans, okay, they can have about 55% of the trans content. This one is known as a low cis butadiene rubber. So kalau you lihat kat sini, dia punya cis content dia hanyalah 35% sahaja. But for this butadiene rubber, you can see that the TG is slightly different. Macam ni you lihat ada beza sikit antara TG, tapi dia punya jarak tu tak terlampau jauh. Tetapi kalau you nak gunakan melting temperature bagi high cis BR adalah lebih tinggi berbanding dengan low cis BR. Okay, second kita bercakap stereoregularity. Okay, stereoregularity in the chain is important about the single bond and it is called as a tacticity. So this tacticity only occur in the single bond. Kalau kata tadi isomer occur in the double bond. So they will produce either cis and trans. Meanwhile, in the stereoregularity is occur in the single bonding. So hanya berlaku dekat single bonding, you takkan jumpa dia dalam double bonding. Okay. So dalam single bonding, that it is called as a tacticity. Kalau katakan double bonding tadi, kita panggil dia sebagai isomer. Okay. So in the tacticity, you have 3 elements, iso, syndio and atactic. Saya tak perlu nak sentuh banyak sangat sebab awak dah tahu dah in term of the properties. Okay. Tapi kita nak lihat in term of the stereoregularity, okay, atau stereoisomers. So in the stereoisomers ataupun stereoregularity, the arrangement of the repeating unit will determine either they are iso ataupun syndio ataupun atactic. Okay, the the difference between the repeating unit arrangement. Okay, so ingat in the technicity, it is about the arrangement of the side chain. Okay, ataupun the arrangement of the configuration or arrangement of the repeating unit for that polymer. Sebagai contohnya, kalau katakan polypropylene, okay, so kalau polypropylene dia punya repeating unit adalah CH2, and then dia ada carbon CH, dan juga dia ada satu methyl group yang attach kat carbon tadi CH3. Okay, so for this one, this is a repeating unit for the polypropylene. So the arrangement of this repeating unit is considered as a tacticity. So there can be a different either they are atactic ataupun syndio ataupun iso. Okay. And this arrangement kita nak mudahkan, kita panggil dia sebagai head to tail arrangement. Maksudnya ada bahagian yang kita panggil sebagai head, ada bahagian yang kita panggil sebagai tail. So how this head to tail arrangement will determine the tacticity of the polymer. Okay, sebagai contohnya, contoh tak berapa jelas sangat. Sebagainya contohnya kita ada polymer, okay. This one is monomer, okay, monomer of the CH2 double bond CF2. Okay, kita ada fluorine kat sini, dua fluorine atoms. So, untuk carbon yang pertama, this one is considered as a head. Untuk carbon yang kedua, this one is considered as a tail. Okay, so this is the repeating unit for this polymer. Okay, because this is the monomer. So, when they polymerize, they will become the single bonding. So this is considered as the repeating unit for this polymer. Okay. Sebagai contohnya you lihat kat sini. Okay, kita ada CH2, CF2. So this is a repeating unit for this polymer. So the arrangement between this repeating unit, either they are head to head, or tail to tail, akan menentukan sama ada dia adalah iso, syndio ataupun atactic. Sebagai contohnya, katakan kita ada head to tail arrangement. Okay, so kita ada sini, kita tahu yang carbon yang attach dengan fluorine is considered as the tail. So sini kita label sebagai tail. Okay, manakala carbon yang attach to hydrogen akan considered as a head. Okay, so kat sini dia akan jadi head to tail arrangement ataupun tail to head arrangement. Selalu kita panggil head to tail arrangement. Sebab apa? Tail dia akan sambung pula dengan head untuk second repeating unit. Okay. Meanwhile, untuk yang second pula, head to head arrangement. Kalau you perhatikan kat sini, carbon yang attach to hydrogen, head. Okay. So dia akan attach ataupun dia akan link dengan carbon yang attach dengan hydrogen juga. So dia akan jadi head to head arrangement. Manakala tail to tail arrangement pula, kita tahu yang carbon yang attach dengan fluorine adalah tail. So dia akan jadi tail to tail arrangement. Okay. So bila ada dia continuously link, okay, you akan nampak lah either they can be considered as an iso, syndio ataupun atactic. Okay, ni another example. So anything lah, kalau R ni anything, it can be either CH3, it can be either Cl, fluorine ataupun OH dan sebagainya, depends on the polymer. Okay, so there can be either head to tail arrangement. So head to tail arrangement can give either iso or the syndio because it occur in the regular, but it can be either in the same side ataupun in the alternate side. So head to tail arrangement normally will give iso and also the syndiotic polymer. Meanwhile, head to head arrangement ataupun tail to tail arrangement normally will give more towards the atactic arrangement. Okay, sebab R dia mungkin akan berada pada kedudukan yang berbeza. Okay, and in polymer chain, it might be formed the combination between head to tail to tail, and head to head. Maksudnya arrangement 3 ni tadi mungkin akan berada pada polymer chain kita. So bila ada arrangement ketiga-tiga ni dekat you punya polymer chain you akan jadi atactic. So apa? Dia punya arrangement akan berlaku secara random. Okay, so head to tail will give either the iso and also the syndio. Meanwhile, head to head possibly give the atactic. And if there is a combination between head to head, or to tail dalam satu polymer chain, it will give the atactic polymer. Okay, so saya skip yang iso, syndio dan juga atactic sebab saya tahu awak dah tahu dah benda ni. Okay, awak dah familiar. Okey, so ini contohnya. Okey, kalau kita lihat dalam polimer, so R ni you boleh replace dengan anything, any functional group. Sebagai contoh, kalau PP, you boleh replace dia sebagai CH3. Kalau styrene, you boleh replace dia sebagai sebagai benzene. Okey. Okey, polyvinyl chloride, you boleh replace R ni sebagai Cl. Okey. So bila you lihat arrangement antara polimer ni, katakan ini adalah tail, ini adalah head. So bila nampak head akan link dengan tail. So arrangement dia akan berlaku dengan sekata lah, head to tail and then head to tail, okay, and then head to tail dan sebagainya. So dia akan continuously head to tail, okay. So dia akan produce the isotactic. Sama juga dengan yang ni, syndio pun sama, okay. Dia akan berlaku dengan sekata, so dia akan bagi the syndiotatic. Kemudian atactic pula. So the difference between the iso and tactic sama juga macam cis and trans tadi. They will give a different properties. Isotactic, syndiotatic, normally they will require high energy for the bond to alter the bond, okay, to break the bond. So they require high melting temperature to be processed. Compared to the atactic, they require less temperature, melting temperature to be processed, because in the atactic they are more amorphous, in the isotactic they are more crystalline. Okay, branching and cross-linking pula. Okay. Branching and cross-linking, it is a distinction between the branch and cross-link, because sometimes students, they are confused. Okay, either they are branching or cross-linking. So this is the illustration between the branching and cross-linking. You can see the branching is about the chain growth at the carbon. Okay, so this main chain, okay, and then they have a side chain that grows at different directions. So this one possibly be the branching for this polymer. Meanwhile, the cross-linking, it is about, as you can see here, cross-linking also link the carbon to carbon. Same goes to the branching. They link the carbon to carbon. But what makes the term as a branching and what makes the term as the cross-link? So kalau you lihat kat sini, carbon yang ni akan link dengan carbon yang kedua. Saya labelkan ni sebagai satu, ini sebagai dua. So carbon satu dan carbon dua akan link sekali. Sama juga, ini adalah carbon satu dan ini adalah carbon dua. Okay, pun akan link sekali juga. Tetapi kenapa carbon untuk yang kes yang pertama dipanggil sebagai branching, kes yang kedua dipanggil sebagai cross-linking. Okay, untuk branching, it occur when there is a growth of a polymer at different polymer chain at a different direction. Like this one, this polymer chain, they grow at ataupun they propagates at this carbon. Okay, so this might be happen because you polymerize ataupun you do the grafting, okay, you do the reaction between the polymer, you combine between the polymer, so they will attach to any carbon, okay, to any active site, okay. So they will grow another chain here. So this one is considered as a branching. So only occurs when you react the different types of the polymer or you apply a different polymerization technique, okay, you use the different catalyst, okay, so they will have a different the different branching, okay. Meanwhile, cross-linking is different. Cross-linking, even though there is a reaction between the carbon to the carbon, but it involve the linkage of the polymer chain. Kalau yang ni tadi, okay, they growth another pendant group. They growth as a side group for the main chain. But in the cross-linking, okay, let's say kalau kita nak tunjukkan diagram polymer chain awak. So, this is polymer chain yang pertama, A. Okay. And then you have another polymer chain, B. Okay. And you vulcanize ataupun you cure ataupun maybe you use the any cross-linking agent, sulfur or anything that can be a cross-link agent. So this one, this cross-link agent will attach in between, will link in between A and B. Okay, they link between A and B. So what happens when they link? They will be cross-link. Okay, so normally in the branching, you still can break the bonding, but in the cross-linking, it is impossible to break the bonding because cross-link is considered as a chemical linkage. Chemical linkage will be the covalent ataupun or covalent and also covalent or ionic bonding. So this considered as a primary bonding. So you cannot break the bonding. Okay. So that's why in the branching, the polymer still can melt. When you apply the high energy, the polymer still can melt. But in the cross-linking, you apply high energy, you apply the high temperature, the polymer will not melt. Okay, because they has been fully cross-linked and they are linked by a chemical bonding, which is either ionic ataupun covalent. So both are primary bonding. So they cannot be breakage. Meanwhile, in the branching, kalau you gunakan temperature yang tinggi, the bond will be broken. Okay, ini contoh yang mana melibatkan propagating, branching and cross-linking in the structure of the polyhydroester resulting from the monomers bearing a primary and secondary hydroxyl. Okay, ini contohnya. So, kita ada monomer yang pertama, okay, kita ada hydroxyl group dan juga kita ada secondary hydroxyl. Okay. So, kalau you perhatikan dekat sini, ini adalah polymer chain yang pertama. Okay, so polymer chain yang pertama. Dan this polymer chain, when you react, there will be a cleavage of the chain. So, they will have a branching here. Okay, same goes to this one. They will have the branching here. But then, when this branching react with another polymer chain of this polymer, so this area will be cross-linked. Okay, this one dia tak pakai sebarang cross-linking agent, cuma dia berlakunya reaction between each other. So they form the linkage. So this one is a cross-linking. Meanwhile, at this point juga berlaku reaction, okay, but this polymer, okay, they doesn't react with the other polymer chain. So this we consider as a branching only. Okay, so when they link between two different chain, they will be cross-linked. When they does not link between the polymer chain, they will consider as a branching. Okay, this is the difference between the branching and cross-linking that occurs in the same polymer molecule. Okay, in the branch polymer, the requirement for the branch polymer, first, the branch polymer can be formed when at least one of the monomers has a functionality greater than 2. Okay, benda ni saya dah tentu dah masa you punya lecture yang pertama dulu, yang mana kita terangkan pasal classification of polymer structure. So kita lihat dah sikit berkaitan dengan branch dan juga linear, crosslink dan network. So kat sini saya dah terangkan, masa tu saya dah terangkan dah apa requirement untuk branch polymer. So first requirement dia is at least one of the monomers has a functionality greater than 2. Let's say dia ada functionality such as hydrogen, ataupun dia has a functionality as a CH3 and so on, so they can grow as a branching. Either, and the second requirement pula adalah melibatkan polymerization process. Seperti mana yang you lihat di sini, ini adalah polymerization process and they grow at this active center, they grow as a branching. Okay, so this second requirement, they occur due to the polymerization process. Okay, they produce a branching point in the polymer and they are made exclusively by functional monomers. So in the branching, Okay, it occur via the replacement of some atom from the polymer chain with the substituent. Okay, sebagainya contohnya macam kita ada CH3 dan sebagainya. So they can produce a slightly branching. Okay, so in polymer, okay, kita ada simple branching and also apa ni? The branching that considered as a dense, okay. Contohnya paling mudah kita ada block copolymers, okay. But then kita ada star polymer, so they grow as a branching here, okay. And then we have a comb polymer. This one is a branching, okay. Branch polymer, this one is a branching. Dan kita ada macam-macam jenis lagi, okay. Ini adalah contoh-contoh untuk branch polymer. Meanwhile, for the crosslink polymer pula, okay, crosslink polymer paling mudah you always observe in the rubber, natural rubber, okay. So in the crosslink polymer, the polymer is connect between with the others individual polymer molecules, and crosslink they are characterized by covalent bonding. That's why in the crosslink polymer, the bond cannot be broken, okay. So once you dah polymerizekan dia, you dah crosslinkkan dia, polymer awak tak boleh nak melt lagi dah. Okay. So that is a properties for the crosslink polymer, and it is not only occur in the natural rubber. Contoh yang you lihat tadi, this one occur in the others polymer as well. Okay, when they can form the linkage between the others chain, so they can form the crosslink. Yang paling mudah yang selalu kita akan nampak adalah di dalam natural rubber. So this bonding, okay, between this is a rubber chain, CH3, rubber bond, okay. So this rubber chain, they will link by the sulfur, okay, elemental sulfur. So this sulfur can react as a cross-linking agent, okay. So they link between this rubber chain, they link at the carbon, okay. Labelkan. So they link at this carbon and they link at this carbon, okay. So this sulfur, when they link between this carbon, these two chain, they form the covalent bonding, ionic or covalent bonding. And ionic and covalent bonding, they consider as a primary bonding, which means that you cannot break the bond. Okay. Okay, so properties of the crosslink polymer. Okay, crosslink between the polymer, they are stronger than regular bonding. If you compare between these primary bond and secondary bonds, such as hydrogen bonding, dipole, van der Waals, okay, all that secondary bonding, they can be broken when you apply the high energy. But for the crosslink polymer, okay, they have a very strong strong linkage, okay, strong bonding, okay, compared to the others intermolecular attraction. And for the crosslink polymer, they cause the polymer to be very stable and also stronger. Okay, you require an extra high energy to alter that polymer. And these crosslink polymer, they occur in the synthetic and also naturally occurring polymer. And normally the crosslink are formed through the chemical reaction. Okay, you can use a chemical agent such as sulfur. You can use another crosslink agent to link the polymer. And then vulcanized rubber is one of the example whereby you link the rubber chain using the sulfur. So the sulfur molecule, they form the covalent bond in the rubber polymer chain and they result in a very stiff and rigid polymer, making a rubber very durable. And crosslink can be explained by the degree of the crosslinking. Normally, you can find or you can study the degree of crosslinking by the swelling, swelling test. Okay, so the relation between the swelling and swelling ratio and crossing density will be vice versa. Okay, let's say when the polymer having a low degree of crosslinking, there will be more swelling. So kalau you lihat kat sini, low degree of cross-linking, they will absorb more water. But when they have a high degree of cross-linking, they will absorb less water. Kenapa dia jadi macam ni? Sebab kita boleh illustrate. Okay, bila polymer awak adalah slightly cross-link. Contohnya macam ni. Okay. So, bila dia slightly cross-link macam ni, you boleh nampak there's still a lot of the empty space in between these two polymer chain. So when they absorb the water still can penetrate into this space. Okay. But when your polymer is heavily cross-linked, sebagai contohnya, bila kita ada polymer network, contohnya kalau heavy cross-link, dia represent macam ni, okay. And then they form the network, okay. So you can see the space is limited. So when they absorb the water, okay, water go into this empty space, and this empty space actually they already dense, okay, they already dense. They having a lot of the cross-link point, okay. So when water absorb, they can only absorb a very small water contents, okay, compared to a slightly cross-link polymer. So when we relate between the cross-link and absorbance, okay, you can see that highly absorbent polymer, okay, okay, when they can absorb more water, okay, when they can absorb more water, they will have a low degree of the cross-linking, okay. Okay, kita nak apply kat mana cross-link polymer? One of the elements is in the super absorbent polymer. Okay, so in this polymer, let's say you compare between the absorbent material. Okay, you have a super absorbent polymer, you have the absorbent, the normal absorbent material, maybe the clothes. Okay, contohnya you punya baju dan sebagainya. So bila you wipe the water and so on, the clothes still have a tendency to absorb the water, okay, because they are absorbent materials. But when you let's say you press or you you push that absorbent materials, okay, they will release the water back. Okay, this is the normal the normal condition of the absorbent material. But when they are highly cross-linked, when they has been cross-linked, when you want to remove the water, okay, you can see that this material they will retain the water. Sebagai contohnya kita ada dalam contohnya macam gel macam ni, okay, they retain that water ataupun they retain the the solvent that they has been absorbed. Okay, you cannot remove that water back. So this happen. Okay, let's say for this one, this is a hydrogel ataupun super absorbent polymer. So this one, they can be the absorbent materials. They can absorb the, but then when you press these materials, they will not release the water. Okay, they will not release any fluid that they has been absorbed. Okay, why they did not release? Because this one already absorb the water and they retain the water due to their cross-link elements ataupun cross-link structure. Okay, so dia tak akan keluarkan balik air tadi. Okay, okay, ini adalah summary, okay, untuk perbezaan antara branch dan juga cross-link polymer. So you boleh baca nanti. Okay, last one, kita lihat berkaitan dengan intermolecular forces. Okay, in the forces, in the inter and intra-chain forces, okay, you can have either two types of the forces. You can have a primary forces and a secondary forces. So primary forces is known as the intramolecular forces. Secondary forces is known as a intermolecular forces. Okay. So how it can be represented? Okay, kita gunakan simple illustration macam ni. Contohnya you have two atoms, hydrogen, chlorine, hydrogen, chlorine, hydrogen, chlorine. So when this one has been, this atom, you have the hydrogen atom and chlorine atom. So when this polymer has been combined together, hydrogen will form, will stick to the chlorine, same goes to this one, okay. And then due to certain forces, okay, they will attract to another molecule. Like this one, you have the hydrogen chlorine and hydrogen and chlorine, but they will attract to each other, okay, due to the certain forces. Okay, so when you remove the forces, you pull these elements, what happen is this hydrogen and chlorine will still attach together, but this hydrogen and this chlorine will be separated. So this is the illustration what happened between the intramolecular forces and intermolecular forces. So the green area, this one is considered as the intramolecular forces, the primary forces. Even you apply the energy, you pull these elements, they cannot be broken. Okay, so this one can be either a covalent or ionic bonding. Meanwhile, this element is known as the intermolecular forces. Uh, so this one is considered as the secondary forces whereby they can be broken. Okay, they can be broken. Okay. So intramolecular forces, they are forces that hold atoms together within a molecule. Meanwhile, the intermolecular forces, they exist between the molecules. So as you can see here, okay, this one is the hydrogen atoms. Okay, this one is the chlorine atom, Cl. Okay, so these two atoms, they will link together via the intramolecular forces. Okay, because intramolecular forces, they hold the atoms together. So this hydrogen atom and this is the chlorine atom. And in the next elements, you still have the hydrogen and also the chlorine. Okay, this is the hydrogen atom, this is the chlorine atom. Okay, so these two atoms is linked by the intramolecular forces because intramolecular forces hold two atoms together. And HCl, these HCl, they are molecules. Okay, this is the atom hydrogen, atom chlorine, and combination between hydrogen and chlorine will be a molecule. Okay, mole saja molecule. Okay, so this molecule HCl can combine with another HCl molecule via the intermolecular forces ataupun secondary forces. So bila you apply energy, this one can be broken, this one cannot be broken. Okay. Okay, next contohnya. Okay, intramolecular forces and intermolecular forces. So intramolecular forces is between hydrogen and chlorine, between the atoms. Meanwhile, between these two molecules, this one is considered one molecule. This one is considered as the one molecule. So the linkage between these two molecules is known as intermolecular forces. Okay, same goes to this element. Okay, this one is considered as the intramolecular forces, sama ada covalent ataupun ionic ke apa. Okay, ni more towards the covalent. And these forces, yang lihat yang dia putus-putus ni, this one is the secondary forces whereby this can be the hydrogen bonding. Hydrogen bonding is a secondary forces. Ya, ataupun dia panggil sebagai intermolecular force. Okay, so dalam primary forces, we have the covalent bond and ionic bonding. Meanwhile, in the secondary forces, you have the dipole forces and van der Waals. And last one, we have the hydrogen bonding. Okay, so for the covalent bond, it is between the atoms that having a similar electronegativity. Okay, so they can, in covalent bond, it can be the non-polar covalent and polar covalent bonding. Okay, sebagai contohnya, apa yang dimaksudkan non-polar? Let's say you have a similar atoms like this, chlorine and chlorine. Okay, so the difference between the electronegativity is less than 0.5. So this one is considered as the non-polar covalent bonding. Second one, we have the polar covalent bonding, whereby you have a different in terms of the electronegativity. Okay, so the different in terms of the electronegativity is between 0.5 and 1.9. Okay, antara contohnya kita ada hydrogen dan juga chlorine, ataupun hydrogen dengan oksigen dan sebagainya. So this is known as a polar covalent bonding. So anything that link the atoms together is considered as the covalent bonding. Okay. So beside then the covalent bonding, okay, you have the ionic bonding and metallic bonding as the intramolecular forces, as the primary forces. So these three is considered as a primary forces. Contohnya ionic bonding yang kita ada, contohnya antara sodium and chlorine dan sebagainya. So this one is linked by the ionic forces. Okay. Okay, in the forces that arise that consist in the polymer, they will have a different strength. So when they have a different strength, you require a different energy to alter the bonding. You require different energy to process the polymer and so on. Okay, so we know that we have two types of the forces: intramolecular forces and intermolecular forces. So the strength will be increased from the intermolecular until intramolecular forces. So if you can see here, you require high energy to process these materials, okay, these polymers ataupun these element, okay. Meanwhile, you require less energy for this polymer, okay, ataupun for this bonding, okay. So okay, tadi kita ada intramolecular forces. Now we look into the intermolecular forces. Okay, intermolecular forces is the forces that arise between the molecule. Okay, that arise between the molecule. So these forces, they are weak and they can be broken by certain energy. Okay, so the first one we have the dipole forces. So in the dipole forces, this one occur when the two atoms having difference of electronegativity and they are bonding together. This result in the resulting bond is not absolutely non-polar, but bears negative and positive charge of the extent proportional to the difference of electronegativity. And this bonding is known as the dipole forces. Okay, so the greater the difference of electronegativity, the greater the intensity of charge and greater the dipole. Sebagai contohnya, between this HCl. So this HCl, hydrogen and chlorine, they are linked by the intramolecular forces. Contohnya macam covalent bonding, okay. But in between this molecule 1 and molecule 2, they are linked by the dipole forces. Ni dia panggil sebagai dipole forces. So these dipole forces, they rise due to the attraction between the negative and positive. Okay, so they have the attraction. But this one, when you apply the heating, you heat this polymer, okay, this one can be broken. Okay, this is a dipole forces. And dipole forces also arise in the polymer. Let's say you have this polymer chain, okay? You have this polymer chain. So this can be linked together via this dipole forces because of the attraction between electronegativity, okay, between the positive charge and negative charge, okay. So this one can be linked by the dipole forces. Unless if you have the cross-linking agent or any polymer that can link these two together, okay, so this will be the cross-link ataupun this will be the covalent bonding. But this one is the nature of the attraction, whereby when they have a different electronegativity, they will attract to each other, okay. So this is known as a dipole force. This one can be broken. Same goes to this one, okay. It can, this polymer chain can be close together because they have the attraction that is known as a dipole forces. And then we have the van der Waals forces. Okay, the polymer chain can also be linked by the van der Waals forces. So this one occur when all the molecules attract to one another, since the nucleus of the each molecule exerts slight attraction on electrons of the other molecule, so that the molecule come nearer to each other. Sebagai contohnya, ini dipanggil sebagai van der Waals forces, van der Waals bonding. Okay, antara polymer chain tadi. Okay, so this can be another attraction, okay, between the polymer chain. Okay, sama juga macam dipole tadi. This one, when you apply the energy, they can be broken. And last one is the hydrogen bonding. Okay, macam dipole dan juga van der Waals tadi, they have the attraction between the negative and also the positive. Hydrogen bonding, they have another special requirement whereby the reaction must be ataupun the reaction can be induced when there is a presence of oxygen, nitrogen, fluorine atoms in the polymer. Okay, and also the hydrogen. Okay, so these hydrogen atoms, they can form the linkage for the between the oxygen or nitrogen or fluorine. Okay, so this is known as the hydrogen bonding. Sebagai contohnya, okey, kenapa yang ni tak panggil dia sebagai hydrogen bonding? Okay, disebabkan kalau you lihat, ini adalah atom hydrogen, ini adalah atom oksigen dan ini adalah atom hydrogen. So this one is not considered as the hydrogen bonding, walaupun saya dah mention tadi, dalam hydrogen bonding, hydrogen ni mestilah attach dengan fluorine, oksigen dan juga nitrogen. Okay. Sebagai contohnya, oksigen attach dengan hydrogen macam ni. But this one is not considered as the hydrogen bonding. This is a covalent bonding because it is between the oxygen and hydrogen atoms. So any bonding that hold the atoms together, it can be the ionic ataupun covalent bond. So kat mana berlakunya hydrogen bonding ni? Bila ada molekul seterusnya. Contohnya macam H2O. So ini adalah H2O. Okay, H2O. So this is one molecule. So this molecule, they will attract to another H2O. They will be linked with another H2O. So this H2O, this linkage is known as the hydrogen bonding. Okay, so hydrogen bonding is a secondary bonding whereby when you apply the energy, they will be broken. Okay. Sama juga yang berlaku dalam nylon 6, okay, whereby we have this polymer chain, okay. So this nylon, there we have the carbonyl, okay, C double bond O, and then we have the NH, okay. So this carbonyl oxygen from the carbonyl can attract to another hydrogen at the adjacent chain. Okay, so this one is considered as the hydrogen bonding. Okay, hydrogen bonding. So sama juga dengan nitrogen di sini, NH kat sini. This one is linked by the covalent bonding because nitrogen and hydrogen is different atoms. This one is linked by the covalent bonding, but this hydrogen and the next oxygen will be linked by the hydrogen bonding. So you jangan tersalah. Ini dipanggil sebagai covalent bonding. Antara ni yang dipanggil sebagai hydrogen bonding. Okay. Contohnya macam yang ni. This one dipanggil sebagai covalent bonding. Okay. Tapi this one dipanggil sebagai hydrogen bonding. Okay. Okay. So sama jugalah. 966. So tu saja untuk chapter 4. Okay. Ada persoalan? By the way, kalau you ada soalan apa-apa boleh WhatsApp saya secara personally. Okay.